Okay, so moving on to chapter 3, we're going to completely change gears and start focusing on probability. So we've got some vocabulary we kind of need to go over first. These come from the framework of your notes that are linked on our agenda. So a sample space is basically everything that can happen. Not necessarily what you want to happen, but everything that can happen. So for example, we have 3 coins, regular head tail coins. We don't know all the possible outcomes. So my recommendation is to just kind of be a little organized about this as much as you can. So I think I'm just going to identify them as the first coin, the second coin, and the third coin. We are going to talk about different organization techniques as we go on throughout this chapter. But for now, I just want to make an organized list. So let's say that the first coin is a head. All right. Let's say that the second coin is a head and the third coin is a head. All right, so that's one possibility. Let's keep the first coin fixed at a head, and let's go ahead and keep the second coin, and we'll just change the third one. So I'm just going to try to be a little organized about this so I don't forget any of them. Okay, so swapped the second and the third. All right, now it could be head, tail. Okay, I think that covers all of them if the head is first. All right, let's reverse it now. So if the tail comes first, let's lock them all at tail. And then I'll go through and just change the last one. And then I'll go through and change the middle one, flip that guy back to what it was. And then the last 2 at heads. All right, and if I go through and I count this, I think I get 8. All right, so those are all of my possible outcomes. That's my entire sample space, everything that could happen. A pair of dice are rolled. What are all of the possible sums? All right, so we could organize this. Or, you can think about if I roll a 1 on the first one and I roll a 1 on the second one, well, then my sum is going to be 2. If I roll a 1 and then a 2, I'm going to sum of 3. Okay, so then 4, 5. All right, so if I go all the way up to rolling a 1 and then rolling a 6, I can get a sum of 7. So I guess the question that I want to ask myself is, I know that I can get a sum of 2, 3, 4, 5, 6, or 7 with just a 1 involved and the second die changing. Well, let's see if we can up whatever the largest one is going to be. I don't think my sum is going to be lower than 2 for sure. But if I go through and I think about all of the different possibilities, again, we could organize this, but I also think that it might just be easier to just try to figure out what we think the sums are going to be because we're pretty familiar with dice. And I think that the smallest sum is going to be when I roll a 1 and a 1, that's 2. And then the largest sum is going to be when I roll a 6 and a 6. That's going to give me a 12. I don't think I'm going to get anything above 12, and I don't think I'm going to get anything lower than 2, but I think I'll be able to get everything in between those two. So again, you could write it all out if you want to, but I think we can just write 2 through 12 here. So that represents all of the possibilities. Okay, independent events. All right, let's do some highlighting here. Independent events, we're going to talk about mutually exclusive events later. So we got to make sure we're clear on these guys. Independent events, it means that the outcome of the first doesn't affect the outcome of the second. So outcome of the first has no bearing on the outcome of the second. So it doesn't matter what happens the first time, the second time still has its own probability that is independent of the probability of the other one. All right, so an example. If you flip a coin and you get a heads, does that necessarily mean that it's going to affect the probability of getting a heads again? No, not at all. These are independent events. So we would say that the first flip and the second flip are independent of each other. So first and second flip are independent. So we still have an equally likelihood of getting ahead, regardless of what happened the first time. Okay, moving on. Some more vocabulary. Compound events. This is more than one thing happening at a time. I think that name makes sense. So probabilities of 2 or more events happening at once. For example, let's say if 2 coins are flipped, what's the probability of both being heads? All right, so I would probably go through and list out my coins again and then just see what happens here. So if I have my first coin is a head and my second coin is a head. All right, first coin's a head, second coin's a tail. All right, let's reverse them. Maybe it could be a tail, or it could be a tail, head. All right, So I think that's all the possibilities if we only have 2 coins this time. Remember the previous question a little bit ago was 3 coins. It's a probability of a total of 2 heads, both being heads. All right, well, each one of these things is one compound event. So it looks like I have a total of 4 things that could happen. So I know that that means that the denominator of this is going to be 4. Remember that probability is the amount of successes over the total number of possibilities. So however many things are in your sample space. All right, so if we take a look at this, then we're trying to find the one that is both heads. So if we take a look, there's only one of these that is actually both heads. So I would say the probability is going to be 1/4 or 25%. Okay, probability area models. All right, so this is where we go through and we use area models, kind of like we did for multiplying earlier when we're doing like x plus 5 times x minus 7. So one of the things that we've already done earlier, you may have actually seen something like this in your biology class, I believe, when you do Punnett squares. So what we want to do is we have these 2 spinners, and we want to see if we can build an area model of all of the possibilities that could be happening, and within that we want all of the probabilities as well. All right, so I think I'm going to take the first spinner, and you just have to decide personally how you're going to set this up. It doesn't matter if spinner number 1 goes across the top or spinner number 2 goes across the top, doesn't matter. But I basically want to use area model, so length times width, to be able to do this. So I'm going to go ahead and go across the top here. I'm going to call all of these items up here spinner number 1. Now, one of the things that you'll see the book do is it'll actually build the area model based off of the probability of each of those regions. So like if you had a probability of like 72%, they would make sure that you have a length of like 0.72 of the entire thing, or 72% of the entire thing. I'm just going to go ahead and section it based off of the fact that if I take a look at spinner number 1 over here, it looks like I have 3 things inside. So I'm going to do the 3 that I have. So I've got a U, and then it looks like it's an I, and then an A. Now next to each one of those, I'm going to go ahead and put the ratio of it, or the percent or decimal. I'm a big fan of using the fraction, so that's probably what I'm going to do. So if we take a look at this picture, it looks like 60 degrees of the entire circle is going to belong to U. Well, that is 60 degrees out of a total of 360. And then I know that that can be simplified, and I'm going to go ahead and turn that into 1/6. Just make the math a little bit smaller for myself over the numbers. Okay, I comes from that straight line segment, so I think that I is going to be half of a circle, which is 180 over 360, which gives me a half. And then going down to A, which is the last one, well, if you take a look at this, we do have this straight line segment here where U and A look like they make that straight line, and we know this straight line's 180 degrees. All right, so a little bit of subtraction. Looks like A is going to be 120 out of the entire circle. Okay, so that's going to give me 1/3. So I did all of my spinner number 1 stuff across the top. Okay, now, so that's going to be my length. I'm going to think about it that way. Then I'm going to go down here because I got to finish building the area model aspect of this. So now I need my height. All right, so if I do my height, let's go ahead and do this in green. This is going to be spinner number 2. So I'm going to put spinner number 2 down the side. So that's going to be my height. All right, so this is going to be spinner number 2. And then I'm going to go through and do the same thing. So it looks like I only have 2 regions this time. I've got a T and an F. And then I'll build the rectangle that goes with this in just a minute. Okay, T is 90 degrees out of 360. So this is 90 out of the entire circle, 360. But if I simplify that, that's going to give me 1/4. Okay, then if 90 degrees is already taken, or 1/4 is already taken, Then we know 270 is left if you want to think about the entire degree of the circle, or if 1/4 is taken, then the remainder is going to be 3/4. Okay, last thing I think I want to do here is actually make a rectangle out of this. So let's go through and make a rectangle out of this guy so we can get our area model. And then I'm going to go ahead and wherever I have a column, I'm going to go ahead and split it up as well. And then I'm going to do the exact same thing with the rows. So there's my true and there's my false also. Okay, so now I've got this box that's filled in. Okay, so when we're talking about this spinner 1 and the spinner 2, these are compound. These are two things happening at the exact same time. So we want to think about is the probability of spinner 1 landing on U. So I'm going to take a look at this first box here. So we want the probability of landing on U and T. So I'm trying to figure out what goes here. Now, it is an area model. So use what we know about area. If you want to find the area of something, you're going to multiply the two of them together. Use the simplified fractions. It'll make your life a little bit easier. So if I multiply the 1/6 from the U and the 1/4 from the T, this is going to give me, and again, you don't have to write down the multiplication, but these notes are supposed to help you. So I want to make sure we're showing our steps. That's going to give us 1/24. So the probability of spinning a U and then a T with these two spinners is 1 out of 24. So I'm going to go through and figure out the rest of these as well. Again, it's an area model, so we're going to multiply. So to find the next box, we're going to do the base and the height. So we're going to go ahead and just keep multiplying our way through. All right, so it's going to give me 1/4 and a half. So 1/2 times 1/4, that's going to give me 1/8. So let's go through and finish filling these in. All right, so it's going to be 1/3 and 1/4. That'll give me 1/12. 1/6 and 3/4. That will give me, it's going to give me 3/24, but I'm going to go ahead and simplify that to be 1/8. And then 1/2 and 3/4. That'll give me 3/8. And then 1/3 and 3/4. Which if I simplify is going to give me 1/4. Okay, handy little bit of information that you're definitely going to want to know is when you have completed an area model and you look at all of the different values inside of this area model, beautiful thing about this, and this is true every single time, is that if you take all of the areas inside and you add them together, you must get 1. Because it represents 100% of everything that could occur. So if you take all of the fractions, and you can check this in your calculator, and this must be true every single time. This must equal 1. And that because it represents 100% of all possibilities. So it represents everything. That's basically it. It's not going to be more. It's certainly not going to be less. Okay, so now here we've got some example problems. This comes from the book. Still the same idea. So take this moment. This does come from 3-3, and we want to try to set up just the area model. Then we'll answer a couple of questions. So I'm going to go ahead and pause this. I recommend you do too. See if you can set up the area model and then check yours against mine. So this problem is specifically about the Navajo Nation. So if we go through our population and we take a look at this, basically saying that they're classified into two different groups. You're either going to be type O or going to be type A. So I went through and I know that we're comparing two people. So I've got person number 1 and person number 2. I've got the two different things that they could be. Now, I don't want to fill anything inside the box until I know what that is, but I do know what the probabilities are that belong on the outside of the box. So I was told from the problem that 73% would have type O. Now, you guys know that we don't use a percent at all before turning it into a decimal or a fraction. So if we want to do this mathematically, so I'm going to go ahead and turn this into 0.73 for 73% and 0.27. So if I go through and I put those probabilities next to them, now I should be able to go ahead and fill in my area model. So remember, it is base times height for each of these boxes. Okay, so here I've got my area model filled in. Remember, they were doing base times height, like I said. And then I did a quick check off to the side to make sure that all 4 of the numbers inside do add up to give me the 1 or 100% that I was looking for. So then now that we've got this, let's go ahead and see if we can answer a question. So let's say that we have the question of probability that they both have type A. All right, so here's what we're going to do. We're going to go to where type A is for person number 1, and then we're going to go where type A is for person number 2, and we're going to go to the box where they overlap. So it is for the first person and for the second person. In this case, this is going to be the 0.0729. Okay, next question, 3-4. Great opportunity. Take a moment, read the question, see if you can figure out how to set up the area model. Then we'll ask some questions. Okay, so here we have our exhaustive table. You do not have to write down the multiplication that you are doing. So all of the stuff that I am highlighting in the table right now, so the showing of the multiplications, for our class, that's not necessary. I'm only doing that so that you can see where I'm getting my answers from as opposed to just kind of plopping the answers down in front of you. And then what I did before, I was like, okay, I'm set on this. I did go through and add all of the numbers together to make sure that I got 1 to represent 100%. So here's what our table should look like based off of the distributions for the different blood types. So the next thing that we want to do, it's only one question that goes with this, and we want the probability that Nick and Zach have the exact same blood type. Okay, so maybe they both have O. If they both have O, then the probability of that would be the first box, which is 0.2025. Well, maybe they both have A. If they both have A, that's 0.16. Maybe they both have B. If they both have B, that's 0.0121. Or if they both have C, that's 0.00, AB is their blood type. That would be 0.0016. Okay, so each one of these cannot necessarily be affected by the other one, but all of these would represent answers to the question, because if they were both O, that'd be the first one. Both A, second one. Both B, so on and so forth. The question is do they both have the exact same blood type? Well, maybe they both have OO. Or in probability tells us to add. Or maybe they have both A, or both B, or they both have AB combination. And then we would go ahead and add that up and see what we get. And I believe we get 0.3762. So that covers your introduction for 3.1.1.